Okay, and this one, Valentine's Day is dragging you forward with an acceleration of 1.2 meters per second squared. You have a weight of 600 newtons, and the coefficient of kinetic friction between you and the ground is 0.4. They're asking you how hard is Valentine's Day pulling you forward. So that's your force applied. So first of all, we're of course going to draw a free body diagram. You are on Earth, so you have a force of gravity pulling you down. Okay. You have the ground pushing you back up. It's flat, boring ground, not accelerating, so that's our normal force. We have a force applied pulling us forward, and we have a force of friction pulling back. Notice the force of friction is not greater than the normal force because it really can't be. All right, so we're going to start by writing our two equations. F net is equal to mass times acceleration, and that's the one that's always the same. And the other equation is F net, and we're going to make that up using our free body diagram. So gravity and normal force are kind of canceled out here because they're equal and opposite. That leaves our force applied pulling forward, and we have a force of friction fighting that motion. Let's go through and circle what we're looking for, which is the force applied. Just lightly circle it with your pencil. And let's underline what we know. We have the acceleration, and we have a force of gravity. So that's pretty much it. So we're going to have to go find some stuff. First of all, I'm going to focus on this equation because there's two things I don't know in this one, but there's only one thing really left for me to solve before I can get the net force over here. And that's mass. If I knew mass, I could multiply it by acceleration and get my net force. So remember that if you ever know mass, you can easily find the force of gravity and vice versa. And the equation that lets us do that is Fg is equal to mg. So force of gravity was given to us. It was 600 newtons. Equals the mass is what we don't know times 9.8. So our mass is 61.2 kilograms. Mass is measured in kilograms. All right, so now we know our mass, so we can actually find our net force. Let me take that over here, make a little room. F net is equal to mass times acceleration. F net, the mass was 61.2. We just found that. The acceleration was given to us in the problem. So 1.2. So our net force acting on you is 76.4. Okay. So now we know our net force. It's the same in both equations. And we're still going for that force applied. So the only thing really left for us to figure out is this force of friction. Well, the equation for force of friction is mu times your normal force. They gave us mu, that's no problem. The coefficient of kinetic friction. So we can say, all right, we know that guy. And the other thing we're going to need to know is our normal force. They didn't directly give it to us, but they basically did. Force of gravity and normal force are equal and opposite on flat, boring, non-accelerating surfaces. So we know our force of gravity was 600. That's our normal force too. So force of friction is equal to mu, which is 0.4, and our normal force is 600. So our force of friction is 240. Okay, so now we know our net force. We found our force of friction. We can solve for our force applied. I'll write it down here again so you can see it a little less messy. Force applied minus force of friction. So F net 76.4 equals force applied minus 240. And because there's a subtraction sign between them, we're not dividing, we're going to add. And that's 316.4 newtons is equal to our force